Okay, so it says water is dripping onto a surface forming a puddle. In the model, the shape of the puddle is a circle. The radius r centimeters of the circle is increasing at a constant rate of 2 centimeters per second. Using the model, show that dA by dt is equal to 4 pi r. All right, so firstly, they're asking us to find a derivative, right? Now, this is a forming rates of change problem. So what I want to do is just remind you of the chain rule. The chain rule states that dy over dx is equal to dy over du times by du over dx, where u is that connecting variable, right? You could think of it as the du's cancelling out and you're left with just dy over dx. So you're going to do the exact same thing here. So whenever I'm doing these questions, I always set up this expression first. So because I'm looking for dA by dt, I'm going to say dA by dt is going to equal dA over some variable that I don't know times by that same thing over dt, right? The question marks will cancel. I'm left with dA by dt. So the question is now is to figure out what that connecting variable is. So let's go back to our question. They told us that the shape of the puddle is a circle, right? And the radius r centimeters of the circle is increasing at a constant rate of 2 centimeters per second. So I've got a variable r here. So it's probably going to make sense to be r dr, right? But let's just confirm it. So the first bullet point, the shape of the puddle was a circle. That tells me that I can say that capital A, the area, right, would be equal to the area of a circle, which is just pi r squared. And that gives me A in terms of r. And as well as that, this second bullet point, the radius of the circle is increasing at a constant rate. Now, whenever you see that word rate here, it's a keyword. Just think of it as a derivative. You're just looking for dy dx when you see that word rate. Now, because the radius is increasing at a constant rate, that means that I'm going to deal with dr, right? And obviously the radius will be increasing with respect to time. So it's going to be dr by dt. And because it's increasing at 2 centimeters per second, it's going to be a positive 2. So dr by dt is equal to 2, right? And I know A in terms of r. So what I'm going to do is say it's a safe option to just replace these with dr, right? So I'm just going to put dr's there and there. Okay, so let's get everything that we know. So remember, we know that A is pi r squared, and we know that dr by dt is equal to 2. So what I need to do is figure out what dA by dr is, and I have dr by dt. So dA by dr, I can figure out by just differentiating that with respect to r. That's going to be dA over dr, and that's just going to equal 2 pi r. And obviously, I know that dr dt is 2, so I can now plug this into the formula. So I have dA by dt is going to equal dA by dr, which is 2 pi r, multiplied by dr by dt, which is just 2. So therefore, dA by dt is just 4 pi r. And that's it. Finished.